right? So hyperbola looks, these equations look a lot like the ellipse, right? What's different? Yeah, one term is positive and one is negative. That's how you recognize when you've got a hyperbola. And notice we've got the two forms, right? Here's the horizontal form, and here's the vertical form. And what changes in between them? Say again? The sign? What is different in this equation and this equation? You know, kind of it's a sign. It's whichever term is the first term determines whether or not it's horizontal or vertical, right? That since it's this one has the x term first, it's horizontal. Since this one term it's the y term first, it's vertical. The a's and the b's stay the same, right? Unlike the ellipse, it was the a's and the b's that changed, and the x's and the y's that stayed the same. Okay. Right. Now, if we look at a picture of the ellipse, you know, the basic ellipse it has two branches. Each one kind of looks like a parabola. Each one has a vertex, which is where we expect to see a vertex. And if you connect them with a line, that line is called transverse axis, not the major axis, transverse axis. The center is right in the middle of those two, right? That's your HK. It has two foci. One of them is in each branch of the hyperbola. And just like with an ellipse, A is the distance from the center to the vertex. C is the distance from the center to the foci. It's just that now they've switched positions, right? The C is farther away than the A. So A is not the biggest of the three anymore. C is. So that's why we still have this Pythagorean theorem looking kind of thing that relates to three, but this time the C squared is on the left because it's the biggest of the three. Right? So is this example horizontal or vertical? Horizontal because the first term is the x term, the positive term is the x term. Okay, so let's see. What is the center of this thing? 1, -1. So let me go 1, -1. That's the center. Okay, now a squared is 4, so a is 2, which is telling me I should go in the x direction, go 2 to the right, 2 to the left. Okay, what do I do with the b squared or b equals 2? I've got to go up 2 and down 2. Right, and what do I do with those 4 points? Make a box, right? Make a rectangular box. In this case, it's a square box, but and then what do we do with that? Right, then we draw the diagonals of that box, which are asymptotes for the hyperbola. Okay, at that point, you need to remember that you said that this was horizontal. So it means start at these 2 points and draw the 2 branches opening up to the left and to the right. Not up here because it's not vertical. Start here and draw it so that each one is approaching the asymptotes. Okay, and then lastly, we need to know the equations for those asymptotes. And we have a formula for that. Right? Y equals k plus or minus a slope times x minus h. The slope is either a over b or b over a. And it'll be depending on whether it's horizontal or vertical. Since this one was horizontal, we went over a, right? That was the a, and this was the b. So the slope is b over a. If it was vertical, we would have gone up a and over b. It would have been a over b. And so in our problem here, it's b over a. Now, as long as I got that straight, I know all the rest of this, right? The hk is the center, 1, negative 1. The b and the a are both equal to 2, so plug it in. So y equals negative 1 plus or minus x minus 1. And of course, you could write both of those like this. Y equals negative 1 plus x minus 1, which is x minus 2. Or y equals negative 1 minus x plus 1, which is negative x. Which looks pretty good, right? X minus 2 means y-intercept of 2, slope of 1. Y equals negative x means y-intercept of 0, slope negative 1.